Sequences and series using sigma notation. Example 1. We have an arithmetic series where the terms are given by this nth term formula. We want to work out the sum of the first 20 terms. So the first term, using this formula, second term, 20th term. So here are the 20 terms, the first 20 terms of the arithmetic series. The first term is 3, so a equals 3, and the common difference is 2, and we have 20 terms, n equals 20. So the sum of the first 20 terms can be written like this, or alternatively we can use sigma notation. Un represents any term in the series, so we want to work out the sum of all the terms from the first term up to and including the 20th term. So it would be like this: u1 plus u2 plus u3 plus all the way up to u20. An alternative to this, instead of writing un here, well, we know the formula for the nth term. It's this. So we can replace the un with 2n plus 1. Like this. So all three of these are saying the exact same thing. If this form is given, this will always be the nth term formula. The formula for the sum of n terms, the first n terms for an arithmetic series, is this. If we substitute our values in, we get 440. Using the calculator, we can work out the sum using the function, the sum function for a series. So it's 2. We don't put in n, we put in x instead. So there's the nth term formula from the first term up to and including the 20th term. Now this is good for checking. Example 2. This time, instead of the letter n, I'm using the letter r, but it doesn't make any difference. And I want the sum of all of these terms, and you'll notice we're not starting from the first term. We're starting from term 10 up to and including term 20. These are the terms, and again we can generate them by putting the r values into this formula. So r equals 10, so 3 times 10 minus 2 gives us 28, and r equals 20, 3 times 20 minus 2, 58. Remember that the first term in the series would be u1, which is 3 times 1 minus 2. So that's the actual first term. That's what a is equal to. It's not this. It's not 28. Yeah, this is not the first term in the series. Yeah, 28 is not the first term. The first term is 1, so a equals 1. And the difference between the terms, as we can see, is 3. So we have an arithmetic series, first term 1, common difference 3, and we want the sum of all the terms from the 10th term up to and including the 20th term. So it's not this. S20 means we want to work out the sum of all the terms starting from the first term up to and including the 20th term. So that would be u1 plus u2 plus all the way up to u20. And we don't have that here. We've got 10, 11, 12, all the way up to the 20th term. Not this. So this is wrong to say we're working out S20, the sum of the first 20 terms. This is wrong. So this is what we're working out, starting from r equals 10. Instead of UR, I can replace this with the formula above that we had, 3r minus 2. And these are exactly the same. Now on the calculator, it would be 3x minus 2, starting from the 10th term up to and including the 20th term, 473. But you can't show this to an examiner. We still need to use the sum of n terms formula for a arithmetic series, and the method will be this: S20 minus S9. So the sum of the first 20 terms, starting from the first term up to and including the 20th term, are all of these terms here. And then we're subtracting the sum of the first 9 terms, which are all of these. And you can see that these will cancel because you're subtracting all the way up to here. And what are you left with? You are left with all of these, which are exactly what we want. 10th term up to and including the 20th term, the sum of all of these terms. S20 and S9 we can easily calculate using the formula. So here's the formula, and for S20 we substitute our values in, we get these, and then for S9, the sum of the first 9 terms, we get these values, and then if we subtract those, we get 473. Example 3, we want to calculate the sum of this. Now the formula for generating any term in the series is right here, and we start from the 5th term up to and including the 12th term. But this is the formula, just this bit highlighted, that generates each individual term in the series. So k equals 1 will give the first term. If we put in k equals 2, second term, k equals 3, and we can see this is a geometric series. The first term is 5, and we're multiplying by 3 each time. The common ratio r is 3. So if we were to list out all of the terms, u1, u2, u3, all the way up to u12, what we want are these terms. But if I work out the sum of the first 12 terms, we've actually worked out the sum of all of these. And from there you can easily tell, oh, we don't want the first 4. So we work out the sum of the first 12 terms using this formula, and from that we subtract the sum of the first 4 terms. So we get rid of these, and we're left with the sum of all of these terms, highlighted in green. A common mistake would be to do this. We're not getting rid of the 5th term, we want the 5th term, and all of these. So using the formula, S12 is here, minus S4, and the sum that we're looking for. For practice, have a go at these questions.